Hello and welcome back. Let's talk about linear dependence. I was going to say lines and planes again, but it kind of does tie into it. So first let's talk about our lines and planes. Well, remember that if we had some point in a plane and we were given two vectors, we'd be able to make a plane out of that. But here comes the problem. What if, let's call this vector u and v, what if this vector u was just some scale of the vector v, say 2v, or 1/2 v? Well, if it was 1/2 v, then what we would actually have is just this vector right on top of it, just half the length. And the problem with that now is all we have is a line. And if you use the parametric equation for a plane, what you're going to see is that you get x equals p plus tu plus, or tv plus su. Well, if v is just 1/2, or u is just 1/2 v, well, this is going to start to look a whole lot like this. If these are both just parameters, we can call them a new parameter. Let's call it epsilon. Well, now we just have the equation for line. So that works. It's a good way to think of it. Well, why do we care about this so much? Well, we have situations where we want to know, is something just replicating the behavior of something else? Say if you were an economist or a businessman and you wanted to know, I have 3 oil plants, and is one of them just performing the same as another one, just at a different rate? Well, then we can just move all those workers to the other oil plant and have the same thing and not have to pay the property taxes on that other one. That's a bit of a tangent, so don't worry about that if you didn't understand it. But let's just hop into some examples. Now, what we're talking about here is linear dependence. What linear dependence means is if one vector is a scale or an addition of scales of other vectors that are in the same space, and you're given the space, then that vector is said to be linearly dependent, meaning that it can be expressed as a combination of other vectors. So let's look at an example. We've got the vector 1, 2, 4, 7. We've got the vector 2, 4, 0, 1. We've got the vector 3, 6, 4, 8. And finally, we've got the vector 4, 8, 8, 15. Okay, we've got 4 vectors here. Now we can ask ourselves 2 questions. We can say which vectors are linearly independent or dependent. And we can also ask, how can we express the linearly dependent vectors in terms of the independent vectors? Let's figure it out. Well, we learned a little trick. Well, I suppose we haven't quite yet, but a long time ago we figured out, well, we can just solve using Gauss-Jordan elimination and make this a matrix, set it equal to 0. So what we're going to get is 1, 2, 4, 7, 2, 4, 0, 1, 3, 6, 4, 8, 4, 8, 8, 15, 0, 0, 0, 0. Boom. This is what we get if we just put these, maybe I'll label these, V1, we'll call this V1, V2, V3, V4, this is V1, this is V2, this is V3, this is V4. And now we perform Gauss-Jordan elimination. We want to make this look somewhat like an identity matrix. Well, what we're going to get is this. We've got some rows of zeros. So what this is telling us is that these vectors right here are independent. And these vectors right here are dependent. So v1 and v2 are independent, and v3 and v4 are dependent linearly. What does this mean? Well, that means that v3 and v4 can be expressed in terms of v1 and v2. And you might think, oh boy, this is just a mess. How am I going to do this? Well, v3 is kind of easy. You just look at it. 1 plus 2 is 3. 2 plus 4 is 6. 4 plus 0 is 4. 7 plus 1 is 8. That's not what I meant to do when I said that. Truth be told, this 1 and this 1, keep in mind that this is the row for v3. v3 equals, first row, 1 of v1 plus another 1 of v2. Interesting. We look here. This is v4's row. This means that v4 is 2 v1s plus 1 v2. And you can prove this. 1 times 2 is 2, plus 2 is 4. 2 times 2 is 4, plus 4 is 8. 4 times 2 is 8, plus 0 is 8. And 7 times 2 is 14, plus 1 is 15. So that's linear dependence. Let me just make sure I don't have any other examples. Nope. That's it. It's really quite simple. And in the next video, we're going to be kind of expanding on this knowledge. So thank you for tuning in. I hope to catch you in the next one.